Hey guys, this is lesson check 7.2. So let's do it. Okay. We learned today that all circles are similar. So let's see if we can describe the similarity based on a transformation. So if circle A was at center 2, 7, with a radius of 4, and circle B was at the center 1, so the new center was at 1, -4, then, and a radius of 3, then how did it get there? Okay, this is interesting, right? We could graph this. We don't really have to, but I could graph it. 2, 7. Right? There's my point, 2, 7. And my new center is at 1, -4. 1, 2, 3, 4. Now it's over here. So it looks like to get from the starting point here, I'm at 2. Right? 2, 7. I got to go back 1, down, it looks like 7, and then 4 more makes 11. Down 11. All right, now what would that look like mathematically? Well, notice to get from 2 to 1, I got to go down. This would be left 1, so I move left, right? 1 unit, left 1 unit. And then I need to move down 11. Down 11. So down these 7, go from 7 back down to 0, and then down another 4. So 7 and 4 is a total of down 11. Nice. Okay. Clean that up a little bit. So now, if I take a circle from one location to another, but it's a bigger one, so it does have a radius of 4, and once I move it down to the other one, notice it's going to have a radius of 3, so I need to dilate it. Circle A must dilate, I think. I don't know. Or dilation. I need the circle to reduce, maybe. I'm not sure what they're going to ask here. It gets smaller, right? By a scale factor of what? So our formula we used was old measurement. We could use old radius times my scale factor is my new radius. So if my old radius is 4, right, before we moved it, and my new radius is 3, I can use a little bit of algebra to solve for the scale factor. 3/4. Nice. Question number 2. The triangle has the vertices F, G, and H. What are the image after the sequence? Okay, so on the X, I'm going to add 3. So all these X values, I'm going to add 3. Right, so we get the new coordinate 1, 1, and -1, okay? And then we're going to add 1 to the y, so add 1 to the y values. So we get 2 + 1, 4 + 1, -4 + 1 would be -3. Now it's followed up by a dilation of a scale factor of 2. So that means we're going to multiply by 2. On both the x and the y. So let's take a look. Where would that land us? 1 times 2 is 2. 3 times 2 is 6. 1 times 2 is 2. 5 times 2 is 10. -1 times +2 is -2. -3 times +2 is -6. Okay, so those are my coordinates. Sound good? All right, next question. What is the best description of the sequence of transformation that maps this on top of that one? Okay, so you can try each of these out, or you could also kind of figure out, well, how could we do this? So here's where we started. And if I could move it over, and so that it would be something like this, right? And then shrink it. I want to move it over and shrink it. So that looks like one of these. So move it over. Okay, so let's try this out. What if I moved it left 2, and this would say down 5. So let's try that. 1, 2, left 2, 1, 2, 3, 4, 5. Ooh, I like that. Okay, so this would map on top of there, and now it would fit right there. So what is my width? Yep. Okay, so we like this first part. Now it said followed by a dilation of 3 or a dilation of 1/3. Okay, so it got smaller. So we're going to pick D. And we can kind of check that out. Did this dimension 3 high is the old dimension times the scale factor equal the new dimension, right? So if the old dimension, it was a height of 3. If my scale factor was 1/3, my new dimension is 1. That's perfect. 3 times 1/3 is 1. I could do it with my width too. My old width is 6. And if I multiply by 1/3 scale factor, now my new width of my new shape is 2. And yes, 6 times 1/3 is 2. Nice work, guys. So we picked the fourth one. All right, last question on our lesson check. A, B, C, D appear to be similar. What set of measurements would prove it? Okay. So we know angles are equal, so we need our corresponding angle to equal. So we would need angle D to be 35 degrees. All right, so angle D has to be 35. Okay, so we can't have that one. And then what else do we need? Well, kind of like our map example today, our sides have to make the same ratios. So this one, 9/12. Should make the same ratio as this one, ED or DE. DE over DF. So what are they giving us? If they made DE 15 and EF 20, would that equal the same ratio? So we can do this a couple ways. One way is to just turn it into a decimal and make sure that they equal the same decimal. So let's take a look at that. If I turned 9 divided by 12 in a decimal, I get 0.75. And if I do 15 divided by 20 into a decimal, I get 0.75. Yeah, so I like this one. Now, what's going on with the next one? 16 divided by 21 is not 0.75. It is 0.76, which is not the same ratio. Let's check this one out. 12 divided by 16. Ooh, I like it. So what's wrong with this? Well, look here. Maybe I'm changing my mind. Yeah, guys, hold on. There's a mistake up here. You can see my notation. I need DE to be in a ratio with DF, and they tried to trick me. They mentioned this side. Oh, I don't like that one. So I like the ratio, but I don't like the sides they grabbed. I need DE to be in a ratio with DF because those are the sides that correspond. Beautiful. Okay. And we like it because it makes the same ratio as 9/12. So 9/12 is equal to 12/16, which is equal, both are equal to the decimal 0.75. Great job, guys. See you next time.